Hamill. I work on the machine learning team, but this is not about me. It's my pleasure to introduce to you Jeremy Howard and Sam Lambert, who will be engaging in the Fireside chat today. Sam is currently head of GitHub platform at GitHub, where he oversees not only the world-class infrastructure that GitHub runs on, but also is leading some of the next-generation developer tools and workflows. Some recent examples being GitHub Actions and also experiments.github.com, which you may have seen. And there are many examples of other things that are forthcoming soon, but I can't really talk about that. But I can say that a lot of them are powered by machine learning. Jeremy Howard is currently co-founder of FastAI, which is a nonprofit that provides free and high-quality education about machine learning. Jeremy is also the lead developer of a widely used machine learning library, FastAI, which we actually use extensively at GitHub. In fact, it powers experiments.github.com, specifically the semantic code search that you see demoed there. Previously, Jeremy founded several technology companies and also served as the chief scientist and president of Kaggle, where, by the way, he was ranked #1 worldwide for several years in a row. We are really excited to host Jeremy today. So with that, I'll hand it over to Sam and Jeremy.
Thank you. Welcome everyone to our nice cozy cabin in the center of Soma, San Francisco. Welcome everybody on the live stream. Thank you all for joining us, and thank you, Jeremy, for being with us. So how about you start, for everybody, I'm sure most people in the room know you, but telling us a little bit about yourself, the history of your career, and what brought you to what you're doing now.
I guess I'll probably be the least educated person to sit up here and talk in front of an audience. I don't have any particular academic background other than a major in philosophy, but I started my career in business strategy, worked at a consulting company called McKinsey & Company, spent nearly 10 years in business strategy. I realized that most business strategy is done by kind of interviewing experts and crystallizing their thoughts, and I found that experts don't really know what they're talking about, so I kind of took a different approach, which was to analyze data and use that to try and make decisions. Turned out really well, and after a while I quit that and started a couple of companies which were kind of focused on things where I thought there were opportunities to do things at scale or better by kind of using data analysis. One was an insurance pricing company, which kind of developed this idea of optimized insurance pricing that's used pretty much all insurers around the world now. But it was kind of weird for me because I always thought of myself as somewhat technically incompetent, but as a business guy, more technically competent than the other business guys around me. So when I sold a couple of those companies, I thought I'd try and become more technically competent by entering some Kaggle competitions, and was absolutely shocked when I won the first couple that I entered. I can't begin to tell you how weird that was, because there was all these like academics and stuff who was terrifying, and I didn't know anything about anything. So I kind of realized, oh, solving data problems isn't really about Greek letters and integral signs and whatnot. It's actually just about common sense and hacking around. So I kind of, since then I've decided to focus my time on leveraging that skill and trying to take advantage of machine learning in particular to try and help make the world a slightly better place.
Okay. So speaking about making the world a better place, what do you feel are the most interesting practical uses of machine learning and deep learning?
Well, the reason I started FastAI is because I don't know the answer to that question. So before FastAI, I started a company called Analytic, which was the first company to focus on bringing deep learning to medicine, which at that time, and perhaps still, I thought was the #1 biggest opportunity for societal impact and financial returns in terms of deep learning. But it became increasingly clear that deep learning can be used to dramatically improve the kind of productivity and effectiveness of nearly every job in nearly every company. And I don't know what most people in the world do, or how they do it, or why they do it. So even in medicine, it was clear I couldn't begin to make an impact on all of the areas of medicine where there's opportunities. So yeah, I think it reminds me very much of when I started using the internet just before it started becoming kind of widely commercially available in the early 90s. And I remember thinking, that was when I was kind of starting at McKinsey, I remember thinking, this internet thing's going to be everywhere. Like everything I think of, every business problem I tackle, I think you could do this better by inserting a bit of internet into it. But I couldn't possibly have told you like all the ways in which the internet was going to change, or which one was going to be the most important, or whatever. So I feel like deep learning is going to be at least as impactful, probably more impactful than the internet. I think it'll be as widely applicable as the internet, but I couldn't tell you, exactly which things are going to come first and exactly how it's going to end up looking and all that stuff.
What kinds of industry mind shifts do you think we need to go through before deep learning is as prolific as the internet?
Well, I think this will also happen the same way as the internet, which is that pre-internet companies, on the whole, failed to adapt. On the whole, they died. I think the same will happen with deep learning. It's very hard, almost impossible, for a big company that doesn't have data in its DNA to become a data-driven company. And just seeing that already, like the data-driven companies, like Google in particular, but also kind of Baidu, Tencent, Alibaba, Facebook, and even GitHub are companies that were kind of born on top of the idea of data as being important, and where you kind of look in the senior executive ranks of these companies and you tend to find like engineers rather than necessarily, MBAs. So I think this will keep happening. These companies will, and the startups that are kind of being founded by smart, passionate people who understand deep learning and understand some domain area well, they'll be doing to the big companies what Instagram did to Kodak and what, so I think that's just the way it is. I get a lot of questions from big company CEOs asking me what they can do, and I always try to give them nice answers, but I don't actually think they can probably do anything. I mean, look at what happened with GE, right? Like GE made a real effort to become kind of digital and data-centric, and they set up this big campus at San Ramon and all that stuff, and the CEO personally was very invested in it and just didn't go anywhere, because that whole hiring structure, promotion structure, everything was founded on expertise, not data. Yeah. So it's a tough change to make, particularly with deep learning, which is like, it's not just data, it's kind of data plus algorithms, which is even harder to manage if you kind of don't understand technically what's going on.
So I'm hearing there might be a potential need for kind of a generational shift as well. Do you feel like people entering the industry, maybe leaving college right now, are learning the correct skills to be able to leverage deep learning?
I mean, the main skill right now you need is coding. So that's actually the only prerequisite we have for our course, is a year of coding, or high school math. So I'd say on the whole, no, but the good thing is that people can do it themselves now, one industry I'm particularly familiar with because of Analytic is radiology. I have a lot of friends who are, on the whole, young radiologists who are just going into or going through their residency, who have kind of gone through our course, and I would say are like world-class deep learning practitioners, and they're also radiologists, and like that kind of, like stuff like radiology or physics or astronomy, they're all areas where you have to be highly numerate to do it, and so like for radiologists to jump into deep learning, it's actually pretty easy, compared to the stuff they have to learn about how MRIs work and blah, 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 it's a walk in the park. And it's great. I mean, now like we're seeing, recently a big pneumonia detection medical imaging competition was won by one of our students who is a radiologist who went through the course and, is now the best in the world at medical imaging analysis for pneumonia. So I think that's the trick. It's not about the universities keeping up, because they don't. It's about people going outside that system and learning themselves.
So research, medical research, drug development are traditionally quite conservative. How did they go about introducing these practices to an organization that may not understand it, and even just getting permission to use the data?
It's tough. I mean, so look at what just happened in the world of drug discovery. Hundreds and hundreds or thousands and thousands of people have been studying protein folding for many years. It's a fundamentally important thing in drug discovery. There's a competition that runs every 2 years where, in theory, these giant companies that do drug discovery and drug production have research groups entering this competition. And then this year, for the first time, DeepMind decided to enter. All of 10 people in that team, none of who knew what they were doing. They didn't know anything about drug discovery. They just chucked deep learning at the problem. And they absolutely smashed everybody else, kind of at the same level as when like ImageNet was first cracked with deep learning. Like everybody, so that entire industry now is looking at each other going, whoa, what just happened? Like how can we, who are meant to be the world experts in this, who have studied it for decades, how does it turn out that we're rank amateurs and a bunch of computer nerds, from Google killed us? So, I mean, so what you kind of see when this happens, it's kind of like what happened in computer vision when Hinton and Krzyzewski did this in the ImageNet competition. All the computer vision specialists I knew in 2012, all the older ones were like, not interested, it's not really understanding images, blah, blah, blah. Every PhD student I knew switched their research to focus on deep learning. And so now you've got, a big cohort of kind of mid to late 20s postdocs and stuff who understand how to actually do stuff with images 1,000 times better than any of their professors do. So I think we're going to see the same thing happen in medical. We are seeing the same thing happening in medical imaging and certainly in drug discovery, and gradually and increasingly, the next big one to fall is becoming NLP.
Okay, so I want to get an understanding from you. What went into the early creation of Fast AI? What did you see? What did you want to do? What kind of made you wake up one day and think, this is something I want to go into, this is how I want to build it? What inspired you to get started?
So I actually gave a talk about this quite a couple, a good 2 or 3 years before Fast AI started, which is now on TED.com. It's called The Wonderful and Terrifying Implications of Machines That Can Learn. And it was that understanding that it was very, very obvious even back then that, perception was just going to keep getting better and better, and language understanding was going to get better and better, and all these things are going to get better and better at an exponential rate. And in Western countries, where about 85% of jobs are service jobs, which are all kind of based on the very things that deep learning is exceptionally good at, the job market's going to be decimated. And there are two totally possible outcomes. One is this kind of fantastic utopian outcome where productivity is massively higher and we all get to kind of enjoy the benefits of kind of farming out intellectual tasks the same way that we farm out kind of energy tasks to electrification and engines. Or, we could see the status quo thing would be that the people that control the data and the algorithms will become richer and richer and richer, and inequality will get worse and worse, and that'll eventually lead to violence and misery and all that. So they're both totally reasonable outcomes. Probably some jurisdictions will have one and some jurisdictions will have the other. But the kind of status quo default one would be the dystopian inequality version, because that's that's what actually happened for decades after the Industrial Revolution. You know, the so-called Luddites, who we now think of as being kind of like, you know, poor chaps who didn't really understand what was going on and didn't appreciate the greatness that was going on around them. That's not what happened. What happened was that median wage decreased. There was great human misery in this kind of inequality that popped up, and child labour suddenly became exceptionally common, and you know, so for the average person, life was worse for a long time. So, you know, the answer is not like, well, let's not have the Industrial Revolution. The answer would be like, well, maybe this time around we can manage it better. So I thought the best way we can manage it better would be to make sure that the tools, the technological tools, are in the hands of as many people as possible and kind of in the hands of like normal people. Whereas like in 2012, 2013, I didn't really know anybody doing deep learning who wasn't kind of young, white, well-educated and male. You know. But now I've just come back from NeurIPS, where there was a big full-day Black in AI workshop. Lots and lots of our students were there. 680 people, you know, flew to Montreal for Black in AI. ICLR, one of the big conferences, is going to be in Ethiopia in 2 years' time. You know, we're really seeing this happen. And so it's really exciting to see how, you know, thanks to many people, but, you know, I think including ourselves, we're starting to see deep learning become more accessible, and hopefully that will slightly decrease the probability of this dystopian outcome.
Do you think the sort of societal incentive structures have changed enough to ensure that we won't have that dystopian outcome?
No, certainly not. I think it's still more likely than not the dystopia will happen, particularly in the US, because, you know, the kind of culture here is, you know, very much kind of founded around this idea of like people are successful because they work hard, and they're not successful because they're, you know, not making an effort, and the right way to fix that is more incentives to work harder or whatever. Or else when you come to a situation where most people can't add economic value in the way that it's currently measured, you know, in a society which is more founded on the idea of kind of fair go and everybody having a chance, the reaction to that is like, okay, well, let's make sure we redistribute the wealth appropriately. Or else in the US, I suspect the reaction will be like, well, let's make them suffer more so they try harder. So that definitely worries me a lot. But I don't know, I just hope that if we can, yeah, put the tools and the understanding of the tools in the hands of more people who are kind of making policy decisions and who understand more of kind of how the world works and the world's problems and so forth. But I don't know, we might have some better chance of sorting it out.
So a question we get pretty often is, are we going to make the developer obsolete? If we keep investing in tools that may allow us to have machines generate more code, do more work. So we do get that question. I would like to pose the same question to you. Is there a world where the developer becomes obsolete?
Yeah, of course. I mean, there's a world where nearly all kind of those intellectual endeavors becomes obsolete. You know, the future world clearly will be one where the most important human tasks are what today is widely generally considered women's work. You know, it's the tasks of kind of care and, you know, like stuff like that. They're going to be the important tasks. So like in medicine, the tasks which are currently largely done by nurses will be the important tasks, because you can't replace them with a machine. You know, you just can't have a machine that provides the same kind of human contact by definition. But yeah, I mean, so that's a big change. And so for developers, of course, I mean, you go back to 1962, when the inventor of machine learning, Arthur Samuel, wrote an essay, which is largely forgotten now, in which he made two bold claims. One was that one day, everybody will have their own computer, which is crazy thinking. And the other is that one day, people won't get those computers to do things by writing code, but will get them to do things by providing examples of what they want. So a lot of people thought he got one right and one wrong. I think he got both right. And to me, you know, our goal is to make it so that people can solve useful problems with deep learning without any code. So for me, the fact that we still require 1 year of coding prerequisite before you even start our course represents a failure on our part. And so until we get rid of that prerequisite, and then eventually, get rid of the course. When I started using the internet, if you wanted to use the internet, you needed to know a lot about TCP/IP and Unix configuration files and so on and so forth. And now you just need a phone and maybe an hour at the Apple Genius Bar. That's clearly where we're going to get to with getting computers to do stuff by learning from examples. It's like, hey, computer, here's an example of what I want, and here's an example of what I don't want. And that's how most stuff clearly should be done.
How far do you think we're out from that world?
I've got no idea. I've never been good at guessing times. I've generally been pretty good at guessing where things are going to end up, but not how long it takes to get there. I think from a technology point of view, we're already at a point where we could and should be doing far, far, far more with these tools than we currently are. So, for example, in software development, I think the kind of current focus on code is a bit misplaced. I just don't see the people in the human-computer interaction world who are really asking the questions like, hey, how can we have human-computer interaction entirely founded on giving examples? About the only person I've seen that do this really well is Brett Victor. Brett has this great essay on magical ink in which he describes how you could write an app he wrote, which actually was an award-winning app without any code. And he said, hey, if you told the computer this with this example and then put this color there and then told it that, it could figure out this. That to me is really exciting because it's the kind of tooling that you could put in the hands of radiologists to help them build a better radiology tool, or activists to help them build a better activism tool, or whatever.
So you're trying to teach many, many people a lot of difficult concepts. What are the pain points? What is difficult? What are the concepts that are difficult to get across? And maybe, is it the medium that causes those issues? Is it fundamental misunderstandings that cause problems? What are you struggling to get across and out there?
Well, the hardest by far is the coding. And not just the coding, but the whole environment around that. And it's improved a lot in the 3 years we've been doing this. So when we started, I had to set up a machine instance, AMI template on Amazon Web Services, and I had to write documentation saying here's how you SSH and create a tunnel, and here's how you install Jupyter Notebook, and then here's how you use GitHub to clone the code, and here's how you run it. And it's we lost, I'd say well more than half the people who started lesson 1 couldn't get to the point that they had the first notebook on their screen. So things are a lot better now. We've got things like Cressel and Paperspace Gradient, and actually the real heroes in this last course I think have been Google. A guy called Slava at Google Cloud Platform has basically set up their official PyTorch and FastAI image, which was just officially available as of today, but it's been in preview for a while, where now with the official Google Cloud Platform image, you can literally click a button and it pops up a running Jupyter Notebook with all the FastAI lessons pre-installed. So that's getting easier, but it's still it's still code.
Yeah.
So that's one. And then another is just, other than our library, there's not really any libraries which put the current best practices, in your hands by default. Mm-hmm. So even Keras, which, was kind of the gold standard in this area for, that's what we started our course with, you still have to write about 35 lines of code to do the most basic computer vision fine-tuning exercise, which is kind of the simplest, impactful thing you can do in deep learning. And it's not just the 35 lines of code, it's that each of those lines of code contains all these parameters you have to set and things you have to remember and things you have to understand. So it's concepts. So, we're trying to make it so that if you want to do, image super resolution or language generation or NLP classification or collaborative filtering or whatever, you just literally run the same line of code, just feed it different data. And we're kind of actually getting there now, and that makes life a lot easier. It's also a lot more. It's also a lot more encouraging because the first thing you try, if you use our library, it almost always actually works.
Right.
You know? So for our new course, we've actually got this fantastic forum thread where I just put something up and said, hey, if you've got some good results to share, post your reply here. And there's something like 800 replies now, and nearly all of them basically say like, I can't believe this. I just tried this random thing, you know, and it worked first time, and holy shit, you know. Even like we've now got a thing where you can put it in production with like a couple of lines of code.
Awesome.
And so now, like, you know, we run this big international fellowship program where people can join for free from anywhere in the world. So one lady from Trinidad and Tobago had this thing of like, here's something that you can use to find out which Trinidadian hummingbird you're currently looking at. It's a Trinidadian hummingbird detector. You know, all the way through to one of the top people at Human Longevity International, Craig Venter's startup, has now done 3 state-of-the-art various genomic classification models, again, coming out of this same forum thread. So I think if you can, yeah, make the tools easy to use and put them in the hands of domain experts, they can do much more interesting things than highly intricate tools in the hands of machine learning experts.
Mm-hmm. That's great. So I have one more question before we go over to the audience and allow them to ask you questions for a little while. So I'm going to ask you a potentially difficult one. I would like you to make one prediction for deep learning and software engineering for the next 5 years. What do you think is definitely going to happen?
I mean, I don't think it's particularly bold to say that, deep learning will surpass human experts at, most perception and understanding tasks that we can think of, whether it be summarizing and extracting information from medical texts or generating totally believable synthetic video and audio or whatever. I mean, it's we're pretty close to there already. People don't quite realize that. And that's that'll impact every industry.
Okay. So if you have a question, we have about 15 minutes for questions. Please raise your hand and then wait for somebody with a microphone to come to you so that everyone can hear and people on the live stream. So please, if you have questions, do raise your hands. I really hope some of you have questions. Okay, nobody has questions, so we will continue on chatting. Maybe Hamill has some stuff to ask. So I feel like at the moment there's a slight fear and aversion from people that don't understand deep learning and the implications. And the obvious one is that people go to like mass job losses and people being replaced. Do you think it's a genuine fear? Do you think there is a hopeful message in this future?
Yeah, it's both. That's why I said like wonderful and terrifying implications. There will be mass job losses and they won't be replaced because it's not like in the Industrial Revolution where it's like, hey, humans used to do all the putting energy into things tasks and it gets replaced with engines, but still you've got all intellectual tasks. Once you get rid of the intellectual tasks, there isn't another category, other than, as I mentioned, the kind of the care tasks, which currently are not generally recognized as being economically valuable. But the really cool thing is that we all have the ability to use deep learning to do really impactful work right now, and almost nobody's doing it. And one of the reasons for that is the vast majority of the people that know how to do deep learning have machine learning backgrounds, and most of them don't really know anything else much, so they don't know what problems to solve or where to get the data for those problems. And this is why you see most deep learning, examples of deep learning at the moment are just stupid, trivial things that really make no difference to anybody. So the opportunity is for domain experts, lawyers or paralegals or activists or doctors or farmers, or mechanical engineers to do cool things in their jobs, which they know, oh, I wish I could automate this, or I wish we could make this better. And so the really good news is that if you're one of these people, then you can. It actually turns out that, it only takes, as long as you've got a year of coding background, a couple of months to become a genuinely effective deep learning practitioner that can actually do useful things in your domain area. So to me, that's really exciting. It's really liberating. We've had examples of students from our course who there's a 16-year-old person from Bangladesh, high school student who did amazing deep learning work that was kind of globally recognized. I mentioned the radiologist example already. There's just I mentioned the Black and AI conference. One of the speakers at that conference was the student from our course. In fact, I was amazed at how many presenters at the NeurIPS conference came up to me and said they got their start in AI.
That's awesome.
From Fast AI, and nearly always it was I used to be an X, where X was some interesting, challenging job, a systems engineer or an astrophysicist or whatever. I used to be an X and did the course, and now I'm combining that with deep learning, and here I am presenting at NeurIPS. So I think there's a huge opportunity. At GitHub, for example, you guys are already doing some really cool stuff with deep learning right now, including Hamill, who introduced us, who got his start from Fast AI as well. I think at GitHub, there's so many things I could think of which you guys could be doing even better if you injected some deep learning into it. I think it's an example full of opportunities.
So we have a question from the audience.
All right, hello. My name is William. I'm actually curious to know, what is Fast AI doing to prevent latent biases from being encoded into some of these models from artificial intelligence or from machine learning or whatever that affect people like me?
So what are we doing to avoid latent biases being encoded into the models? The thing we're doing is to try to teach people about this issue, because we can't change everybody's models, but what we can do is help to make sure that people are aware of it. So we actually incorporate data ethics teaching directly into all of our courses. And one of the things we teach, in our Part 1 machine learning course and our Part 1 deep learning course is about the impact of encoding bias into models, and also trying to get software engineers to recognize that they can be both part of the problem and part of the solution, which is something that a lot of engineers don't realize. They think, I'm just an engineer, it's not my problem, or researchers, I'm just doing research, it's not me, it's not my fault, it's not my problem. But the truth is that biased data leading to biased models can have extraordinary knock-on effects that go far beyond, that can basically make that initial bias much worse. So, for example, in the justice system, there's this disastrous program called Compass, which is used for, judges use it to be told what kind of sentence to give, and it's also used for making bail recommendations. And when you actually look at the the confusion matrix, if you like, it turns out that it very, very frequently tends to let out white people on bail who go on to reoffend, and does the exact opposite to black people. And with these kinds of things, like predictive policing is another one. Companies like Palantir are kind of helping right now American jurisdictions with predictive policing. The thing is, because of the bias in the systems in the US in particular and other countries, there tends to be a larger amount of black people getting arrested. So, for example, with marijuana, you're something like 6 times more likely to be arrested if you're black than white, even though you're just as likely to smoke marijuana. So with that kind of underlying societal bias, that then leads to biased algorithms. And then the feedback loop, which is horrifying, is that that causes predictive policing algorithms to send more police to the black neighbourhood, therefore being more likely to arrest more black people, therefore feeding back data into the algorithm. So, you know, it's actually engineers that have to take responsibility for stopping this, even though they might not normally be part of the kind of product release cycle. The people who are in that product release cycle don't understand enough about the computer systems to know what questions to ask or how to avoid it. In fact, this is one of the big problems with algorithms in general, is that we've all learned as a society to be kind of overly credulous of algorithms. So judges are pretty likely to recommend sentencing, to agree with sentencing guidelines from a computer because the computer said it. Whereas from a human, they will ask questions and push back against it. So this is like a bias in how humans work, is we tend to believe, you know, machines more than we should, and we don't know how to ask them questions, we don't know how to push back against them. So that's what we're trying to do, is to kind of teach the problem and also teach the idea that people need to take responsibility for being part of the solution.
Yeah. So it's not just enough to take the job and do what you're told.
No, and you know, this goes like, there's so many examples of this in history, all the way back to at least to World War II, where, you know, IBM found they had a huge marketing opportunity to show that their new cross-tabulating machines were incredibly successful for cross-tabulating fast data sources. And, you know, so they got a big contract with Nazi Germany, and they were able to correctly and quickly encode which Jews were sent to the gas chamber, and, you know, which gypsies were going to be sent to concentration camps, and so forth. And now, you know, historically, you know, a Swiss judge looking into this, you know, found that IBM was directly, partially responsible for the Holocaust. You know, or more recently, in interviews, folks, you know, army captains and so forth, responsible for the genocide in Myanmar, where babies have been ripped out of their mother's arms and thrown onto bonfires, literally. One of the greatest causes of that was Facebook's recommendation algorithms, which, desperate to get more clicks, know, you know, the algorithms know that more clicks are created by recommending more controversial content, and it creates these feedback loops. And so in Myanmar, particularly combined with the fact that they previously didn't have internet, and Facebook literally gave people free internet as long as you only used Facebook. So they had this kind of echo chamber and this filter bubble, and it was, again, it's clearly been partially responsible for a genocide. So, you know, it's been going on for a while. It's going on right now. There'll be people watching this who are at the companies we're talking about. It's certainly not just Facebook. I mean, YouTube has recommended Alex Jones videos something like 70 billion times now. People watch Fast AI videos and tell us that the next thing they get recommended is like white supremacy, conspiracy theories. So, you know, these are all because of runaway feedback loops in recommendation systems that are built by people like us. So we've got to get our shit together and stop doing it.
Yeah. Another question from the audience.
You touched on it earlier that you think that machine learning will dominate fields that are based on perception. There are some people who argue that machine learning will eventually run into a wall when it comes to training computers to make creative, ethical decisions, and those types of pursuits, the actual decision-making from the data. Do you believe that another technique beyond machine learning will be necessary, or do you think that there is an evolution of current techniques that will enable that type of application?
Well, we're already doing that a lot. I think part of the problem is that there's a group of pundits who are extremely interested in the question of artificial general intelligence, and so they always kind of cast progress in the question of like, is this like a brain? Is it going to create a brain? And I totally don't care about that question. I don't think it's very interesting. But the question of like, can you use this, you know, algorithm which has rapid and accurate perception, you know, the object recognition capabilities to rapidly help make decisions? That's a very interesting question. So we can absolutely right now install a piece of software in front of a medical imaging scanner which intercepts the DICOM message and identifies that there's a high likelihood of a stroke here and makes the decision to send an alert to the hospital saying like, urgent attention needed, possible stroke victim. And you already have 3 hours to respond to a stroke. So something like that is an incredibly valuable decision to make more quickly. So I think, to me, the current technology we have right now, we barely started to scratch the surface of what it can do. So kind of the question of like, are there some limitations to what it can do? We're kind of so far away from seeing those limitations. I guess I don't feel able to answer the question. I also don't feel it's a question we need to answer right now because there's just so many opportunities to use what we have.
I have another question for the audience. Thank you.
Two questions. One short one. So, what is the short-term to medium-term future for Fast AI Library? And the second question is the U.S. position to remain the leader in AI, deep learning, machine learning in 2 to 5 years?
Just say the second part of the question again. Is
U.S.
Oh, US. So the first part of the question was, what's the plan for the Fast AI library? So the kind of the short-term plan is to keep adding more application areas where the same 3 lines of code will get you a world-class model in that area. So currently we have object localization and classification in computer vision, NLP classification, tabular regression and classification, and collaborative filtering, all basically the same 3 lines of code to get a world-class result. We've nearly finished doing the same for image generation. So it's really cool. We've now got to a point where you can get better than GAN results of image generation without needing a GAN, and it takes only about an hour on a single GPU to train it. And then, so as we build these different applications, in each case we create kind of a scaffolding of abstraction layers so that then other researchers can come in and try pulling bits out and replacing them with other bits. So for example, with our NLP classification stuff, at GitHub, you guys did a really good job of pulling out some of the pieces of how we were doing NLP classification and replacing them with code, kind of text classification. And so that's the kind of research work that we're going to keep trying to help people build. But, the ultimate goal, as I said, is to get rid of the need for code entirely in these applications because it's really shouldn't be necessary, and it's really important to creating accessibility of this field that we get rid of the need for code. Will the US maintain a leadership position? I would argue that in many areas the US no longer has a leadership position, at least in computer vision. I feel like China's taking over or has taken over. It's a close call. They're both a lot of good work being done, but if you look at some of the bigger, tougher computer vision competitions, they tend to always be won by Chinese institutions. Whereas it used to be that anybody from China I met who was studying here was like, I'm just trying to figure out how to make sure I don't have to go back to China and stay in America. Things have changed so much now, and people are now saying like, oh, when I'm done, I'm going to go back to China. So there's kind of, the immigration opportunities for America to stay ahead are going to decrease. I think, the other thing about China is there's a really fantastic AI community over there of people who take the stuff in English and translate it to Chinese. So, for example, there was a Chinese nonprofit that took all of our videos and translated them all into Chinese, with our absolute blessing. And also, a lot of Chinese folks read English pretty well. So they have the benefit of all of our research in English, but then they've got all this stuff, a lot of stuff I see only in Chinese, which very few people in the West have access to. So I think it's going to be hard for the US to keep up with that, particularly because there's this, big government level focus on AI in China, and when that country decides to do something, they invariably actually do it.
Yeah, we have time for one more question.
Hi, so you kind of talked on this just recently, but so you talked about ethics and bias in algorithms and models, but I'm curious about what your thoughts are on ethics in data access, and the ways data is being accessed right now, and what you think it might be like in the future.
Could you give an example? What do you mean by data access?
So I guess you talked about with the Chinese government, or the way it's done with Google or Facebook, where you opt in, you're getting something in return, so you say, yes, you can have my data. Yeah, I guess if you have any thoughts on the ethics of consumers understanding the value of their data and what they're giving up when they give their data, and what you think that might be like in the future.
Yeah, I mean, I don't know I've got any particular insights there. I mean, clearly, as machine learning becomes more and more important, which is fed by data, data is going to become more and more important, and so increasingly more and more of the things that we will buy using our data as a, as the compensation, effectively. So I think, yeah, I mean, the ethics of that is difficult because in such a transaction, you assume that buyer and seller have full information, and very, very few people understand what they're giving up. On the other hand, when you actually do the analysis of how much money they would give up in order to get access to Google if they were told they couldn't have it anymore, it's like thousands and thousands of dollars a year. So the value of these goods is extremely high. So, yeah, I mean, so it's going to keep happening more and more, and so I think it's really all about what then gets done with that data. I mean, there's potential for a lot of good to be done. So, for example, I'm involved with a company called Doc.ai, where we're trying to help consumers get access to their medical data. So we provided this app that you can download, and it can literally connect to Sutter Health or Walgreens or LabCorp and download your medical data, which previously was locked up, basically. I mean, in theory, you allowed access to it, but it was no real way to get it. And so then, when you've got all your medical data on your phone, you can literally join these patient and research communities and with financial compensation, agree to have your data used to help medical research trials, which potentially can make people's lives a lot better. So, I think, yeah, I think there's a lot of opportunity for good by having greater amounts of data sharing, but it's extremely, extremely hard to have that done in a way that people are really informed about what it means. So I think it's really difficult.
I actually have one question, if I'm allowed to.
Yes.
Jeremy, I know you're an avid user of GitHub. What features would you like to see on GitHub that might be powered by machine learning or deep learning?
Well, I used to be a Perl programmer, and in Perl there's this concept of do what I mean. And so we always said that there should be some module where you just type use DWIM semicolon, and then it would just write the code for you. So that's what I really want GitHub to do. And I don't think it's that crazy because like a lot of the code that I write is pretty boilerplate. So I would like to see a lot more. I mean, it's kind of where you were going already, Hemo, with your natural language code search. I'd love to see that integrated into kind of VS Code or something in a way where I can type. To me, the way to use deep learning is it should be an interaction between a domain expert and a computer. So in the case of my code, I'm the domain expert, and you're running the computers. So I should type the minimal amount necessary for your computers to have a reasonable guess as to what I'm trying to do. Then it should give me a little menu of the things I'm trying to do, and I just pick one, and it fills out the rest, and I type a minimum additional new characters. To me, that's what all computer interaction should be like. It's like the domain expert provides the minimal necessary amount of information for the computer to have a good guess at what you mean, and then you kind of have this dialogue with the computer to fill out the rest. So can you write that, please?
We'll somehow get that on the
All right.
road now.
Thank you, everybody, for coming. This gets to the end of our conversation. However, there's networking afterwards. There's still more food. The bar is still open. Thank you to Sam and Jeremy for having this conversation at GitHub, and hopefully we'll be launching some of these ideas soon.
Thank you.
Thanks, Amadou.